Hello friends, FIBSC student, Physics and Electronics mainly. I am going to discuss regarding the electronics practical. This is the first practical. Actually, it is a very important practical related with the electronics and physics student. I am Professor D.J. Trivedi. I am teaching in this college since 1987. I am doctorate in microwave electronics and microwave remote sensing. I had worked in an ISRO, etc. Dear friends, this practical, for doing the practical is not that much serious, but by doing this practicals, for you will come to know a different introduction of the different components, introduction different devices and instruments which you are going to utilize throughout your study career up to MSc. So in that respect, these practicals are very important. I have already uploaded the material for the practical number 1, 2 and 3. Practical 1 is related with the passive component, electronics passive component. Practical number 2 is a electronic active component and practical 3 is instruments. So if you understand all this practical, these are the same instrument, the same component, etc. You are going to utilize for three years in undergraduation, and moreover, then after, if you are going to study further, it is utilized in post-graduation also. So in that respect, we'll start with the passive component. Now you should know the difference between active component and passive component. What is the difference between active component and passive component? Active components utilize the energy. It converts the one form of the energy into another form of the energy. It's kind of transistor, field effect transistor, operational amplifier, MOSFET, ICs, etc., which is containing a transistor and MOSFET, etc., is known as a active components, which converts DC energy into AC energy, may be amplified also. But here we are going to study about the passive components. The three main passive components are resistance, capacitors and inductors. Transformer, etc. is also comes under the mutual inductance, that means inductance coil, etc. Switches are there is a relays are there is a potentiometer is there, but all these things comes into passive components. So dear friends, I am going to explain you first the resistors, and the related with the resistor, the theoretical knowledge of the resistor already you have studied. Carbon resistors. In a carbon resistance, there is a graphite is there, and in a graphite, a different proportion of resin material is introduced. And that way, a different value of the carbon resistance is going to be prepared. Maybe from 1 ohms to few mega ohms resistance you can prepare using combination of graphite and resin material in different proportion. This material is very soft, so it is enclosed by some kind of, you can say that making it harder, just like you have seen the pencil. So in pencil it is actually graphite, it is a soft, so it is covered by wooden. Same way here, it is the material graphite, etc. It is also going to be covered by this kind of, you can see that this is the different resistance. So I will show you the resistance here. This will be the resistance, you can see that this is going to be the resistance, this resistance will be there. So these are the carbon resistance. They are enclosed by this kind of porcelain material, and there are two ends, they are connected inside, so it will provide the conductivity of that resistance, and in this circuit this resistance can be connected into various circuitry. Now in this one you can see that there are a wattage is also required, written. There are two things actually. On a resistance there is a different color code is there. You can see that here in this resistance there is a different color codes. Here in this resistance there is orange, orange, third color is a black, and the fourth color is a brown. So such kind of color bands are given on each resistance, this carbon type of resistance. You may be surprised why this kind of color bands are there, because this color bands represents the value of that resistance. You have studied in the material I have given, and you have studied in 12th standard also. There is a table was there. You just remind that table. B.B. Roy goes to Bombay via Gateway of India. This sentence you have to learn. B.B. Roy means first B stand for black. That stand for 0. Second B is a brown. B.B. Roy. Then R. R-O-Y. R stand for red. O stand for orange. Yellow. Y stand for yellow. B.B. Roy goes to. Then G stand for green. Then goes to Bombay. B stand for blue. Then violet will be there. Then there is a white. Goes to Bombay via B stand for violet. Goes to Bombay via Gateway. Then grey color here, and W that stand for white, 10 to 9. And that way the power is also there. The first color band give you the 10th value of the resistance, second color band give you the unit value of the resistance, and third color bands give you the power. So that way, by using this one, you can find out the value of the resistance. You may be thinking, why this kind of color band is given? Because the cost of this resistance may be 1 rupees or 2 rupees only. And it can be measured by this kind of multimeter also. This is called a multimeter. You should know about the multimeter. In a multimeter, there are different range of the multimeter is there. You can see that on a screen there is ohm is written, and it indicates that it measures the resistance. It can measure here on a resistance also. This is a knob. By changing this knob, you can measure a AC voltage, you can measure a DC voltage, you can measure a AC current, you can measure a DC current, you can measure the value of the capacitance, you can measure a diode also, that is forward bias and reverse bias, or voltage drop across the diode can be measured. You can measure the frequency also, you can measure the capacitance also, and in some meters you can measure the HAP of the transistor also. So these are the various parameters can be measured by this meter, and hence it is called a multimeter. This comes in your instruments. This is very important device which you are going to learn. Here also there are 4 different holes. The black I have put it in a common mode. That means the one terminal should be referenced with this common mode. We are measuring everything. Depending upon what you are going to measure, another probe should be there. Either you want to measure the voltage, or you want to measure the resistance, or you want to measure the hertz, that is the frequency, or if you want to measure capacitance, then this probe is going to be utilized for that. Another one is a common terminal you are going to utilize. The third one is a ampere, and the fourth one is a very high range of the ampere, that is up to 10 amperes you can measure in that probe. That means this positive terminal you are going to substitute either if you are measuring the current here, or you are measuring the current in high range, and accordingly you have to move this one. So this way you can utilize this multimeter. This multimeter is normally cost around 2,000 rupees. Using this multimeter also you can measure a resistance. But if you buy a 2 rupees resistance and then you are buying a 2,000 rupees for a multimeter, it is not advisable, and that's why we are normally utilizing this kind of color bands to get approximate resistance. So here actually you are supposed to do the practical 2 different way. You are going to put the 2 probes into any of the resistance like this way, and you have to see what is the value of resistance will be there. That value of the resistance will be shown here. Actually it is the mirror image because this is going to be different. So actually it is 3.379. It is showing voltage, and just putting in the resistance range. So it is, you can see that the value of the resistance is 0.989 kilo ohms. Here it shows the kilo ohm. So 0.98 kilo ohms. So approximately 1 kilo ohms is from there. 988 ohms or 1 kilo ohms resistance is there. And if you see the color bands on that resistance, color band shows that the first color is a brown. This brown stands for 1. So 10th unit is going to be 1. Then there is a black. That black stands for 0. That means the 10th unit is going to be 1. The unit is going to be 0. So 1 0 will be there. And the third color is going to be red. So 10 into 10 raised to 2. That means 10 into 100. That is going to be 1000. So from the color code, you can find out the value of the resistance is going to be 1000. So this way, you can find out through the color code also, and you will find out through the meter also. So this you have to write down in your observation table for each one of the resistance. Resistance is also having two different things. Size of the resistance. You can say that they are having a different thickness of the resistance. Thickness of the resistance indicate the wattage of the resistance. That means it can have the same value of the resistance, but it can handle more amount of the current. I square R is called the power. So it can handle, power capability is going to be higher. So wattage capability is going to be higher. That's why the thickness is going to be higher. That represents. And resistance also, there are different type of resistance. You can see that this is a potentiometer. Potentiometer means variable resistance. This is a cap is given on a potentiometer for easy movement, for making a volume control or any other type of the control where resistance is supposed to be movable. Then you are supposed to utilize this kind of potentiometer. Potentiometer, inside there is a wire wound resistance is there. Over a strip there is another contact which is going to be movable. So between these two contacts there is a resistance is going to be changing. You know the value of the resistance is equal to R is equal to rho into L upon A. So area of the cross section is going to be constant. Rho is the resistivity is constant because the material is the same. But if the length is changing, then the value of the resistance is going to be changing. That way, the variable resistance also can be prepared. So the previous resistance you have seen, carbon resistance, they are a fixed value of the resistance. But this potentiometer, etc., is called a variable resistance. So this is a potentiometer resistance, it's a variable resistance. Here also it is a trimmer, small type of the potentiometer resistance. Here there is a small screw is going to be there. So you can vary the value of the resistance and by using the screwdriver. And then whatever value of the resistance you require. Here there will be 3 terminals. Middle terminal is always a variable terminal, remember. So you can measure this value of the resistance using meter also. You can see that how they are going to be changed also. I am putting this meter into middle terminal as well as one of the terminal, and then you will see that the same thing in the meter that is changing. Now if I am rotating this shaft, that means the value of the resistance will be changing. That way the variable resistance can be fixed. It can start from the 0 ohms, the maximum of depending upon the value of the resistance. 1K port, 10K port, 100K port, 1 mega ohms port, etc. is going to be available in the market. In a resistance, there are another things is also available. Thermistor type of the resistance. So this is called your thermistor actually. Thermistor means thermal resistance. You know that. Putting here the value of the resistance you can change using a temperature. So if you are putting a soldering iron or something and the temperature is going to be changing, the value of the resistance is also going to be changing. Otherwise, at the room temperature, its value is going to be something fixed. Then as the temperature changing, its value is going to be changing. there is another type of resistance which is known as a LDR, light dependent resistance. Over there, you can change the value of the light which is going to be falling on that one. Then also, this one is a LDR where I put the probes, and there you can change the value of the lights and the value of the resistance is going to be changed. So this way, you can study a different type of the resistance, and you can measure as well as you can measure using the multimeter, as well as you can find out the value of the resistance using color code. So this table of the color code, B.B. Roy goes to Bombay via Gateway of India, is very important. It is given in that material also, and you have studied in 12th standard also. So that table is utilized for resistance as well as for capacitance also. So remember, this is related with the resistance. Now we'll study about the capacitor. In a capacitor, what is capacitance? You know, capacitor is nothing but two conducting plates which are separated by certain distance. Between these two conducting plates, there can be air or there can be nothing, or there can be a different type of dielectric material. Dielectric material is an insulator. So capacitor is having a different formula. You know that Q upon V, C is equal to Q upon V. Q is the amount of charge which is accumulated on a plate of capacitor, and V is the potential difference which is going to be created across the two plates of capacitor. So that way you can find out the value of the capacitance. Capacitor is also energy storing device. So between the two plates, because of the positive charge and negative charge, there is electric field is going to be exist, and this electric field which is storing the energy, that's why it is called energy storing device. Resistance, which is a dissipating device which is utilizing Joule effect. So energy I square RT, that energy is going to be dissipated in the air in the form of heat energy, and that's why it cannot be recoverable. In a capacitor, this way energy is going to be stored in the form of electric field. In a inductor, the energy is stored in the form of magnetic field, 1 half Li square. I is the current passing through this, L is the inductance, etc. You know very well. So this way, these components are known as a passive components. In a capacitor also, various type of the capacitor are available, depending upon between the two plates what kind of dielectric material you are going to place. If you are going to place a paper, then it is called paper capacitor. If you are going to place a mica, then it is called mica capacitor. If you are going to place another material, then accordingly there is a liquid is going to be there, or electrolyte is going to be there, then it is called electrolyte capacitor, etc. is there. And in capacitor also, there is a fixed value of the capacitor as well as variable capacitor. Just like a resistance, there is a fixed value as well as variable is also available. Now we'll replace the board, so you will understand that this is going to be just a minute, I'm adjusting for you. So I'll exchange the board actually. Now it is a capacitor instead of resistor. So you can see that you will feel the different type of the capacitor. I'll show you here the capacitor. Change. Can't change the camera otherwise. This is the electrolyte capacitor. This is a mica capacitor. This is a polyester capacitor. This is a color code with the capacitor. This is a box type capacitor. There is a Storoplex capacitor. There is a resonator. This is a crystal capacitor. There is a disk type of capacitor. There is a gang capacitor, means there are two capacitor, both are changing that value. This is a trimmer capacitor, so this is a variable capacitor, both are. And this is the fixed capacitor, and that value of the capacitor you are going to measure through the meter. This color band capacitance, the value of the color band capacitor you can find out using the same table which you have studied for resistance. That is, PV Roy goes to Bombay via Gateway of India. Said table you can utilize for finding out this. In a value of the mica capacitor or disk capacitor or color band capacitor, this